In this video, I am going to talk what is ROC and what is AUC. So AUC, area under curve. But before going to know what is these things, how is being used in the data science, what is the purpose to find out the ROC and the AUC. So before that, we should know some terminology, then only would able to understand how to draw the ROC and the AUC. And these things is being used to evaluate any machine learning model, means how your model is good, which model you should choose for the binary classification problems. So first we should know what is the confusion matrix, what is the precision, what is recall, specificity, FPR, and what is the trade-off between sensitivity and the specificity, right? So if you see my previous video, I have explained till now whatever I am showing in the whiteboard. So I would recommend please visit the previous video to have better understanding. But let me recall in just for the 1 minute. So suppose you know that machine learning model. That model is predict or depend upon the model's behavior, they do their work, depend upon the input or text data, right? So suppose you have the image or you have some data. For the time being understand, suppose this is the image. So you have the 10 animals. Out of 10 animals, 1, 2, 3, 4 are the cat. And you pass this data into your one model. And your model is capable to recognize this cat to this cat, this cat to this cat, but this also recognize it is not the cat, but your model is saying this is the cat. And again here this is not the cat, but this model is saying the cat, and this cat to this cat. If you see, your model is able to find out the 3 perfect data. Which one? This cat, this cat, this cat. So that's why this terminology is called the true positive. So if you could able to find out the exact positive, we call the true positive, right? So we have the 3 positive. In this 2 case, it was not the object, it was not the cat, but your model is saying this is the cat. So this is the false positive and this is the false positive. And whatever he could not, he didn't recognize, means he said this is not the cat. And yes, this is not the cat. So this is called the true negative, true negative, true negative. But he say cat is also as an object, but actually this is the cat. So this is called the false negative, right? So these are the terminology. And when you convert all this value into the confusion matrix. So what is the confusion matrix actually? So you have to draw the actual, what is the actual data and what is your predicted output. And you compare both values in the term of the true, false, right, or positive or negative. So if actual true or false and predicted true or false. So if actual is true and you also machine is saying, the model is saying the true, this is called the true positive. Actual is false, you also model is saying the false, this is the true negative. And if actual is false but your prediction is saying true, this is the false positive. And actual is true and your model is saying false, this is called the false negative. Right, these are the things. Now we have some terminology to find out how your model is working. So one is the precision, what the precision is saying. So just consider within box, right, your model, out of all the true positive, out of all the positive, how many are actual the positive, right? Out of complete output of the model, how actually number of the cat, that is called the precision. So formula of precision is the true positive divided by true positive plus false positive. If you see, we are considering the data what is inside the model. True positive, so 1, 2, 3 true positive and true positive or false positive, right? So within the model output is called the precision. So 3 plus 5, we have the 3 true positive and total he predicted the 5. So 3 by 5 is equal to the 0.6, which is the 60%. Second terminal is called the recall. That is also called the sensitivity and that is also called the true positive rate, TPR. Means it shows how your model is good to identify the true value characteristic. That is called the sensitivity. And the formula is that true positive by true positive plus false negative. If you see this value, true positive and this divided by this is called the recall. And in our case, I have given all the value, so it comes to 75%. And third terminology is called the specificity. Specificity says how your model is good to identify the false value characteristic. False is the negative value characteristic. That is called the specificity. If you see, this is just opposite of that. So true negative by true negative and the false positive. And for the remembering purpose, you can also say this is the negative recall, right? This was the positive recall, because taking the positive, and this is negative recall. In our case, this is the 66%. Another terminology is called the false positive rate. This is nothing, this is the 1 minus specificity. So if you formula say false positive by true negative and the false positive is come to 33%. So if you want to define what is the FPR, that is how wrongly your model classify the true value, right? This is called the false positive rate. And I have already explained in the previous video what is the accuracy. Accuracy means in the complete how many your model was identifying out of the complete given data. So if you see, this is the correct, this is the correct, this is the correct, right? All the true value 3 and the 4, 5, 6, 7. So total was 10. Out of 10, 7 my model is able to identify. So this is called the accuracy. Now this is just the revision for the previous video. Now I have to discuss the two important thing. What is the sensitivity and the specificity? Sensitivity this one and the specificity this one, right? So just understand, if you develop a model, and for the time being that model is the binary classification problem model, and we use the logistic regression, right? And you give any patient data, and depend upon the given parameter, your model will tell this is that they would have the disease or they will not have the disease, right? Depend upon the data. So how you can do that? You give the data patient P2, and after giving all the data, your model logistic regression will find out the probability 0.8. For the patient 3, probability 0.4. For the P4, patient 4, probability is the 0.6. So then say is 0.8, then prediction is yes. Chances are there they may have the disease, and you say yes. If 0.4, you say no. If 0.6, you say yes. So on which basis you are saying 0.8 could have the disease? Because you are considering the threshold value is 0.5. This is very important terminology to understand the ROC. So when you consider the 0.5 is the threshold, on that basis you can say this P2 would have the disease and the P3 will not have the disease. But if I say this threshold is the 0.4, then you can say this P3 also could have the disease, right? So based upon the threshold, we are predicting about the output of the model, right? So this is the important thing. So let us, I am converting this data into the one graph. So x-axis has the threshold and the y-axis has the number of observation of the various patient. And in my data set, I have the normally distributed combination of the two kind of data. Some patient has the disease yes, some patient has the disease no. So what happens when you draw this graph, and you can say this the 0.5 threshold, then all the patient they will not have the disease, they will come to here, and they have the disease that will come to here. But condition is not like that. So first of all, you will not have this much of the normalized data, but even though this is not the way, because any model is not able to give the 100% predictions, so must have the overlap kind of things to to uh, when you model is work, you can say some percentage, if this is the disease no, it will overlap with the yes, and some disease the patient have the disease yes, they overlap the no, so it will clear in the next diagram. So let me make one diagram over here for the better understanding, so then you will understand this part. I am going to erase it. So yeah, yeah, so this was the good thing. Now take the same diagram, okay, take the same diagram, and if I say that okay 0.5, so if you draw, so this part is the your disease yes part, and this is no part, and if your threshold is the 0.5, so yes part is this much, right, and this much also, this part is also, your model will say this is the disease yes, but in actual this is part of the no, right. So this part is complete yes, this is the true positive, here is no problem till here, from here to here true positive, no problem. This is here to here, this is the true negative, no issues. Problem is that the patient who would not develop the disease, that is also coming into this area, right, this area. And the same way, the person who might have the disease, that is coming into the no side, if you see this part. So if you say this is the false negative, right, and this is the false positive. Why this is the false positive? Because I am saying this part is, because this is the threshold the 0.5, right? According to threshold 0.5, whatever the data is after the 0.5 is the positive. So this part should be the positive, but actually I know this is the negative part, that's why this is called the false positive. The same way this is the false negative, this is the true negative, and this is the true positive. Now if you shift this 0.5, no, I am going to take my threshold, not the 0.5, I am going to reduce the threshold, right. So when you reduce the threshold, so suppose I am considering my threshold is here 0.3. So what happened, that all the positive is considered the positive, but I have to compromise with the negative value, right. So that's why if you increase the sensitivity, in this case if I reduce the threshold, when you reduce the threshold, so our sensitivity, what sensitivity is saying? Sensitivity is saying that they will identify the true value. So when you reduce the threshold, your sensitivity is increasing, but your specificity is the decreasing. But if you make the threshold suppose 0.7, in this case it covers all the true negative. So in this case specificity is increased and the sensitivity is the decrease. So this is the trade-off between the sensitivity and the specificity, right. So if you understand this part, then what I say that now I am very much comfortable to explain what is the ROC. So what I can say here, okay, so suppose you create one model 1, and on the different threshold, so suppose threshold T1 is the 0.3, for T2, 0.4 threshold. So when you create the model and when you find out the accuracy or the precision, actually you are evaluate your model or you are checking the model performance based upon the one threshold. But that is not enough. This is not a way to find out the model performance, right? So you have to check all the threshold, all the possible threshold. And when you, in this diagram, you have seen that, right? When the threshold is 0.5, our two positive, false positive value was different. When you change the threshold 0.3, you all the four value would be changed, right? So when you shift the threshold, when you change the threshold, for the each threshold, your true positive weight and the false positive weight would be different. Again, for the threshold 4, your true positive weight and the false positive weight would be the different. So that's why ROC is saying that draw one graph false positive weight in the x-axis and the y-axis the true positive weight. And so now, so suppose let me take one here. So suppose for the T1, you make one table. This is called the true positive weight. This is called the false positive weight. So for the suppose for the 0.6, your true positive weight was the false positive weight was 0, and this is suppose the 6 0.6 or something. But this is different. This is the for the not the confusion. TPI is the 0.7. And the same value for the 5, suppose and for the 5, take the example for this is the 0.4 and this is the 0.8. I'm just taking random number. And for the 4, suppose this is the 6, this is the 0.2, and here this is the 3, and this is the 6. Or here for the 4 and the suppose 1. But what happened? Suppose threshold is equal to 0. When you make the threshold is equal to 0, suppose when you make the threshold is equal to 0, so in this example, when you make the threshold 0, I shift this threshold value is equal to 0. So what happened? Everything become the positive. So this positive is positive already. They will consider this two negative also is the positive. So it becomes the false positive, right? So you have the only positive value. So if you put this in the TPR is equal to 2 positive and 2 positive, false negative is there 0. So false negative is equal to 0. So it becomes the 1. And if you check the false positive rate, so what happened? False positive. So we have the false positive and 2 negative is equal to 0 and false positive. Both are cut, it becomes the 1. In the same way, if you check the threshold 1, this threshold I am keeping it here. So what happened? They will consider everything as the negative, right? So this negative is already there. Even this 2 positive also they will consider the negative, and it becomes the false negative. So in this way, when threshold is equal to 1, the TPI is equal to 0 and FPI is equal to 1. This is the case, right? So now, if you here put these two values, T is equal to 1 and T is equal to 1. So this is the 1, 1. And for this is the 0, 0. So now, let us make one graph. This is the x-axis, this is the y-axis. Here put the false positive weight, here put the true positive weight. This is the axis, right? And now, if you put this 0.3, 0.6, so suppose here is the 0.5. Don't confuse, this 0.5 is not the threshold, this is the false positive weight, right? And then if it is the x-axis is 0.2, this is the 6. So suppose this is the 0.2 and this is the 6. So suppose if you make this kind of things, right? and this kind. And here this is the 1, and here this is the 1, right? 1 would be also possible when the threshold is equal to 0, right? And this is 1 is the 0 also when the threshold is equal to 1, right? So when you draw this diagram, right? When you do this is 1. This is called the ROC. This graph is called the ROC. And the area inside that, this area is called the AUC. So now I am going to explain what is the benefit to draw the ROC. Benefit is that if you see here, in this case, I have the only 2 positive. In this area we don't have, and the 0 is the false positive. So according to the domain, in your domain, when you are considering to capture all the positive value, suppose take off the digits things, right? You don't want to skip any digits for the any patient. So what you will do? So you will don't compromise with the positive value. So in that way, you want to put the threshold in such a way so all the positives should be covered, right? And for some other case would be there, some other domain where you don't want to compromise for the negative things. So that you will show this graph to the business expert, to the SME, and they will consider which threshold I should consider. So ROC will help you to find out the correct threshold based upon the business need. This is the ROC benefit, right? Now, what is the AOC? AOC means the area. What is the maximum area could have? Maximum area could be the 1 into 1 is equal to 1. So AOC could be go for the maximum. When it is a max, when the model is perfectly fine, that is called the. In that case, AOC would be the 1. But now think about this is for the model 1. So for the model 1, this is the ROC. For the model 2, suppose for the model 2, this is the graph, suppose. And for the model 3, just very hypothetical, model 3. So now you have the 3 ROC, right? For the model 1, model 2, model 3. And you have to find out the AUC, means the area under each and every ROC. So you will find out for the ROC 1, you will have the AOC 1. For the ROC 2, you will have the AOC 2. For the ROC 3, for the, and this is nothing. This is for the model 1, this is for the model 2, this is for the model 3. Which area is greater, that model you should choose. Right? That's why this is the AOC is really useful. ROC is good for to determine which threshold I have to choose as per your business requirement, and AOC you have to use which model you have to use for the better performance for the model. So in this way, I explained all the things. Hope you would be able to understand. If any questions, let me know. I will try to give the answer. And please don't forget to subscribe this channel and share this channel. Right? Thank you very much.